All right, maybe I'll start. I think it's going to take a little bit of time for people to join, and there's a little bit of preamble as well. And we've got a lot to get through today. So I'm looking at the camera. Here we go. Oh, is there anything you wanted to raise initially, Doha, or should I just go straight ahead?
No, go for it.
Okay, let's go for it. All right, hi, welcome everyone to this call basically, and we're talking today about the Carbon Hack, which is a hackathon which we're running as part of through the Green Software Foundation. The goal is to decarbonize software through a technique called Carbon Aware Computing. The top prize right now is $40,000 US, and we potentially have our prize pool is now at 90,000. It might actually turn to 100,000 in the next few days, but we've got a lot of interest from sponsors and people to get involved. What we're hoping today is just to give you, I am Asim Hussain. I'm the Executive Director and Chairperson of the Green Software Foundation. Here's some links about me, which you can, if you ever wanted to chase me online. If you haven't already registered for the Carbon Hack, please go ahead and register. The URL is grunsuf.org/hack22. I don't know if we have a chat that we can share in this forum, but Doha, if you just share it in the, I don't know if we have that in this type of Zoom, but feel free to share it. And that's how you can register for the hackathon. We'll give you those links a couple more times as we go along. And you know, the Carbon Hack, we've got quite a few sponsors and quite a few judges that we've now lined up. So there's quite a wonderful list of people who industry experts, people who are experts in green software, some in carbon aware computing, and we've got a wonderful judging panel lined up for the final event, and all these amazing sponsors as well. So thank you to all of them. So what am I going to talk about today? What are we going to talk about today? I'm going to give a quick introduction. I'm going to quickly talk about carbon awareness, just to make sure everybody understands on this call, what are we talking when we talk about carbon awareness? And that'll help you if you have any potential ideas regarding some hackathon projects you want to work on, or maybe if you want to just understand some of the projects that other people are proposing. And then Shimon and Dan from the Carbon Aware SDK team are going to be here available, and they're going to be able to demonstrate the SDK and the API, so you can just get a feel for, you know, how does this work? How can you build carbon aware software? And then we're just going to have a bunch of panelists, and we're just going to honestly just have a relaxed conversation about some carbon aware ideas, anything to help inspire you. During this whole conversation, we're here for you. Ask any questions as you go along, and we'll try and answer them. Doha, if there's any relevant kind of questions, please interrupt us as we go along. I don't have everything on my screen at the same time. So yeah, so I'll just go ahead. So very briefly, I'm going to try and be 10 minutes if I can. What makes software green? This is the Green Software Foundation's view. Carbon efficient software that emits the least amount of carbon possible. There's 3 ways: use less energy, use less hardware, and the third one is this thing called carbon awareness. And this is where there's so much interest in this space. If energy efficiency is using less energy, carbon awareness is using the right energy. It's how do you make your applications use the cleanest energy possible? And that's because energy is actually quite dirty. How clean or dirty your electricity is. So all the electricity coming out of my wall socket right now is dirty. It emitted carbon when it was created. That's because most electricity these days is still created through the burning of fossil fuels. 80% is the global average of 80% of the energy in the world is still created through the burning of fossil fuels. That measure of how clean or dirty the electricity is called the carbon intensity of electricity, and its unit of measurement is grams of carbon per kilowatt hour. In 2019, the global average was 519 grams per kilowatt hour. That's half a kilo. Imagine half a kilo of soot ash in your hand. That's what we're talking about per kilowatt hour. And a kilowatt hour is not much. A kilowatt hour is 1/64th of what it takes to charge my car. It's really not much at all. And the really interesting thing about carbon intensive electricity is it varies by location. This is not a complete map. This is only just some of it. You can see the greener areas are the ones which have cleaner energy on average, and the darker areas are the ones which have dirtier energy on average. It typically relates to if a region has more coal plants or natural gas plants, it just has dirtier energy. If a region has more solar and wind and nuclear and hydro, it has cleaner energy. So just different regions have clean or dirty electricity. And so one aspect of carbon aware computing is called location shifting, which is just moving stuff. Like if you were going to run it in, I don't know where that is in the US, somewhere in the US where it's quite a dirty, maybe run it in, I think that's Spain. So maybe run it in Spain. This is just an example, because it could be, on average, it might just be cleaner electricity. So some parts of the world just have cleaner electricity than other parts of the world. Shifting your computation to those regions, that's called location shifting. That's one sub-strategy of carbon aware computing. But the other interesting thing about electricity is it varies by time. So let's say right now, I'm in the UK, right now, there's actually quite sunny right now. There's a lot of solar, there's a lot of wind power. And so the utilities are like, well, there's a lot of sun right now. We don't really need any more electricity. We won't burn as much coal. We won't burn as much gas. And so the carbon intensity, how dirty electricity will be quite low. But you know, the wind stops shining and the wind stops blowing and the sun stops shining. And so in those situations, you have to burn more coal and gas just to mean that my laptop my monitor has enough electricity to work. So really over time then as well, the dirtiness and cleanliness of electricity changes, and it completely varies. It varies by country, varies by usage pattern, varies by how much renewables a region has. So it's very, very dependent on a lot of information. And so then you can imagine running things at a different time actually reduces your carbon emissions, because you know, you may run, if you were going to run it at this time here on the left-hand side of the screen, you'd be using quite dirty electricity. If you were just to wait 1 hour, maybe the electricity will be cleaner and you can run it then. And some interesting studies show that about a 6-hour window, if you can play in about a 6-hour window with your software, with what it wants to do, that has kind of the best return on investment in terms of carbon emissions reduction. So even if you just move by 6 hours is really good. Even 1 hour is good, but 6 hours seems to be quite a good number. And that's called, that previous thing was called time shifting or temporal shifting. And the third technique is called demand shaping, which is, you know, your application just constantly is doing something. Can you make it not stop working, but just do more when the electricity is clean and just do less when the electricity is dirty? That's called demand shaping. So those are kind of the three things you kind of do with carbon aware computing: location shifting, time shifting, and demand shaping, or a combination of one or more of those together. That's really what carbon aware computing is. There's a really great example. I use this all the time, Branch Magazine. This is a really good example. There's many examples. This is a really good example of demand shaping, I'd argue. So right now, the internet, I don't know what it is right now, actually, live. Okay, it's quite bad, that means. But if the electricity was clean, was coming from clean sources, they show full color images. If the electricity is medium, it shows grayscale, which is smaller size and therefore less processing, less energy. And if it's really bad, it doesn't bother in the image at all, and it just gives you text. And so this is just an example of, you know, a carbon aware feature in an application. There's other kind of really great examples, big scale examples. So Google introduced, you know, some work on carbon aware data centers. So not all of their compute, some of their compute just shifts and moves around depending on how clean and dirty electricity is. And they've shown to reduce Google's carbon emissions by about 1%, just with kind of very small investment in carbon aware, you know, computing, data center computing. Windows kind of very recently, Microsoft with Windows very recently now makes Windows carbon aware. So the updates that are happening when, you know, when Windows updates It's now going to try and do that more when the electricity is cleaner and not so much when the electricity is dirty. So, you know, carbon aware computing, it's one of the most hottest topics in green software. It's not just on the edge. Major corporations are really working to release, and this is reaching the mainstream really in a very big way. One of the big challenges though in building anything carbon aware is, you know, everybody's basically doing the same thing. They're asking the same questions. They're building the same logic in their applications. So one of the things the Green Software Foundation did, while the open source working group and the Green Software Foundation are working on, is creating a carbon aware software development kit, which is an API as well. And so what this allows you to do is it's just going to make it, if you're building something carbon aware, use this SDK, use this API, and it'll just make your life easier. And so we have people from this team on the call today. And, you know, next up, I think I've got a couple more slides, but next up, they're just going to go through and demo some of the features of the SDK and some of the features of the API. And these are perfect times to kind of ask questions and, you know, dig into it, into really what we've created. The SDK. Yep, so just a reminder that the grunsoft.org/hack22 is where you go to register. If you've already registered, we will start sending you emails very, very shortly with a lot more information on how to what the next steps are and how to IDA and where to put projects in and things like that. So that's coming up shortly. These are some great links.
I have a couple of questions. Sorry.
Oh, okay.
Cool. Is the SDK sensitive on location time shifting when when calculating the emissions?
Okay, wonderful. Yeah, thank you, Anna. So yes, yes, it is. Unless you're asking whether it does both. I'm not 100% whether it does both simultaneously yet. I think the team will be able to answer.
So yeah, I can take this.
Yeah,
so basically, it by itself is not sensitive to it, but it is taking data from sources which can let you to either do location and time shifting as well. There is an API endpoint that will allow you to get the lowest value either by multiple locations or on a bigger time window. So you could theoretically do both at the same time.
Yeah. Yeah. And the second question from Anna, is can the SDK be integrated into a TypeScript project? 100% yes. The team has, I believe it's 40 languages. There's a client that has an API, and there's 40 languages which you can use the API in, or the API is just JSON, a JSON interface. So you can just interact with it just as you might interact with any other JSON API. Yep, that's it. Awesome.
Yeah, we use OpenAPI Swagger specification to generate that. So you can generate it yourself and see if it works. And
yeah, wonderful. And so Hack20, the first link will take you to the hackathon registration form. The second link will just take you to the SDK, the GitHub documentation for the SDK, it's actually this one. And the third one will take you to our live hosted API, which we're making available. You don't have to log in, you can really try it out. It will be rate limited and a lot of different things. Once you register for the hackathon, and once you register properly for the hackathon, we will then send you keys to get access to your own, API key, so that you're not rate limited and you're not using this kind of shared resource. So this API, it's just there if you want to, for everybody. But if you want to do your own one, we will be sending you keys for that as well. Also, oh, and that's it. So I think now we can go straight away. Shimon, I can stop sharing, and if I can remember how to do that, and then it's you and Dan. I've literally forgotten how to stop sharing. Here we go. There we go. So I think it's now Shimon is going to do a demo of the SDK, and
lovely.
Yeah, we go. Wonderful.
Yep. So let me just open
I apologize,
up this.
Shimon. I was supposed to ask you some questions, but I don't have the right information on the screen. So why don't you just go ahead.
Yeah,
If
I can
asked
start
something.
off by doing like a quick intro of what you can see on the screen. So basically what I have here is I have the SDK, I mean the API of the SDK running and deployed locally on localhost. And what I have here is a Swagger UI to test the API. So what you can do is you could already poll this yourself with HTTP requests, but instead what you have here is like the Swagger API. It's a tool developed by Smartbear, which we also use for generation for libraries for different languages. And what we can do here is just try the SDK out, send it some data, some requests, and get the data from it directly. So for example, if I wanted to poll the emissions by location and endpoint, I can do that straight away by looking at, for example, the UK South region. And what I'll get back is the current carbon density data from it.
Sorry, Shimon, would you mind zooming in just for other people? Would you mind zooming in a lot more? Yeah.
Yep, sure thing.
So Shimon, so what I'm seeing from here is you've made an API request for what time did you make it for?
So because I didn't provide any time, it by default is polling an endpoint to get the most recent time.
Okay, so right now you're saying in the UK it's 462 grams per kilowatt hour.
Precisely, yeah.
That is actually quite high, to be honest with you. I'm quite surprised because it's really sunny outside and I was expecting it to be quite low. So that's interesting. That's interesting, which could be for many reasons. It doesn't, you know, yeah. So, so did you have? I've got some questions for you if you want, or do you want? Or do you have another?
Yeah, sure. We can run through the questions first to just cover like some of the interesting topics, and then we can jump off to covering other stuff as well.
So just show us again how to use this API. So if I was to go to the top there, I can just put in. You've put in UK South. Yep. UK South. Where do I get those names for what I can put there? How do I know what I can put there?
So currently, what it's doing is because we are developing and testing it on Azure data centers. Those are the names of different Azure data centers around the world, which are then mapped to our data providers' region names. Currently, we are using what time and in this particular deployment. So I'll configure it to use what time as the data source.
So what time are one of the data providers that provides this data? So the SDK isn't creating the data. The SDK is just creating like a nice interface towards the data that what time already provides. Yeah.
Precisely.
So if I'm not on an Azure data center, is there another way of putting a location in yet, or?
So at this moment, you would have to find the closest Azure data center that can be put there. But it is just a case of adding a generated file with the AWS regions and mapped to their geolocation, and then we could the same thing for AWS regions or anything else. Okay. So this is a support. This is a feature that's not in the 1.0 release. This is like to be added.
To be added. I see. So what if I now add some? So what you've got these other fields here called time and to time and duration. Like what do they do?
Right. So the time and to time basically allow us to select in what time window do you want the data from. So if I, for example, wanted to get the data from yesterday for like, I don't know, like 12 p.m. Up to 12:30, I can just type it in. So I don't have that particular query ready, but I can just quickly type it in.
Okay. And after you do that, I've got some questions from the audience as well. We can go through.
And what we will get here is we'll get the data in that time window.
So I'm seeing here like that multiple in 5-minute increments, is it? Or
yes. Yeah. So the time intervals that what time provides the data in is in 5-minute intervals, right? And well, with different data sources, that might be different. So you could theoretically then tweak it with duration minutes. I believe it doesn't affect it currently, as it's for what time is only set at 5-minute intervals. But for other data sources, that might be modifiable.
So what I'm seeing here is like in 5-minute increments, it went from a 296 grams per kilowatt hour, then it shot up to 388, 388, 388. Yeah.
Yes. So this is actually 1230. So it actually dropped down. So at 12, so at 11:55, it was at 388, and then at 12:30, it was at 296.
Gotcha. Okay, that makes sense. Let me just there's some questions from the audience. Oh, Dan's tapping an answer to this. Oh, some people typing an answer to this. Okay, I think there's some people typing answers. Let's just go ahead. Yeah, nothing's anything for us right now. But so if I was to do a time shift, like what I discussed before, you know, like we want to, you know, I want to find out what is the best time to run my application or my workload. And I probably have some flexibility. I probably have maybe like several hours flexibility today from now onwards. How would I do that? Or what's the best way of doing that? Yeah.
Okay, so we'll look at it, for example, based on previous day, because for today we don't have past data for future hours. We'd have to look at forecast data, but we could look at the by location's best endpoint. And once again, we're talking about UK South, right? So we can look at UK South, and let's say we're looking at a time window of the entire day of yesterday. So from 12 a.m. up to 11:59 of that day. And what we'll get as a response is a list of best carbon intensity values and corresponding times for it as well. So as we can see, because it's the value is the same for a while, for different times, we don't get a single value, but we get a few suggestions where we could possibly move this to or consider moving it to. So it gets like at 12:30, 12:35, up to 12:55, the rating stays the same at 296.6 grams of CO2 per kilowatt hour.
Okay, cool. Yeah. And just to call, so this is, and we don't want to get too much into the weeds about this, but this is what we call marginal carbon intensity, which means that this is, so what that means is that this is the carbon intensity of the electricity power station that would have to be switched on or would have to produce more energy to service your needs. If I was to turn on my kettle right now, some power station somewhere in the UK needs to make more energy at that moment to give me the electricity for my kettle. So this number here is the how dirty that electricity is, which is very kind of very interesting. So I think we do have a couple of questions.
And I just wanted to add to this that basically the reason why we can use that as well is because we know that the data center is probably going to have a slightly better carbon intensity than the grid itself. But still, if it's in the region where the overall electricity is worse, like it has to still use some of that energy. So if we know that a different location has a much lower carbon intensity, obviously the data center there is probably going to have a better carbon intensity of the electricity it's using, even if it has some solar power and stuff, than one in a dirtier one.
Yeah. Okay. Yeah. So there's one question from Arne. I apologize for saying it wrong. So they are asking is, why is the data so different from, I think they're looking at electricity map right now and actually looking at maybe UK South. you have any thoughts as to why that might be? It could be because we're using what time rather than electricity map. Methodologies are different, or
that might be one of the reasons. I mean, those are different data providers, and they might be using different ways of calculating it.
Right. Actually, I think I might know what this one is actually. So I'm not 100% certain on it. I'm not 100% certain, but electricity map might be showing on their website the average, what's called the average carbon intensity, whereas what time gives you the marginal. So the average might be 276. I'm not 100%, I haven't checked it, but the average might be 276, but the marginal is 480. And what that really means is like the marginal right now might actually be a coal power plant or a natural gas plant. So if you were to use electricity now, you actually are going to burn natural gas. So that might be one of the reasons why it's reporting different numbers between electricity maps and what time. The average versus marginal thing is something that comes up a lot in carbon aware computing. You tend to want to use marginal if you're making decisions regarding whether to shift, and you tend to want to use average if you need to make calculations for reporting. That tends to be the rationale for it. That might be, I'm not 100% certain, but that might be the answer to your question. Asim. Yeah.
Yeah, I think also on the difference between what time and electricity map, I think Navin was or Ismail was typing an answer, but as far as I'm aware, the locations are different, so it kind of is complementary. One provider is complementary to the other, so they've got different data sources and they potentially cover different areas. So in some cases, they might cover a sub part of a country, and then what I might cover a different subpart, and if the country comes up, it's actually different areas. So I think potentially those are things to keep into consideration.
For the duration of the hackathon, we have been very generously being given what time data. So what time is a lot of this data we're showing you is you have to pay for this normally. So what time was provided free data for all hackathon participants for the duration of the hackathon. So that's why we're kind of leveraging and using what time a lot these days right now. So I think some other questions. Go on.
Comment maybe on that. You're right, definitely I can confirm that their methodologies are different. So one does marginal, what time does marginal, and electricity maps does average. I posted the methodological argument for average from electricity maps. I'll post the one from what time as well.
Yeah.
So you can see what the arguments are on both sides. But I think the trends overall should more or less match. So you might get different measurements, but you should have similar hours of low use or high use, which is really what matters, I think, for a lot of our use cases. It's not so much whether we're catching the exact measurement, although that can be one of the use cases, but whether we are using the optimal time of the optimal zone. And for that, both of them should work. And the last bit to mention is that the SDK allows you to plug in your own source. So if you don't like what time or electricity maps and you want to focus on a different one, you, I believe, are able to do that, to just sort of put your own source of data for a location they don't treat or a methodology you prefer.
We also have Henry here from what time?
Oh, Henry will certainly want to. We'll bring him in later on to talk about average versus marginal. I think he's definitely going to have a few opinions on that.
Good morning, everyone.
There we go.
I was just going to say the standard is currently written around a marginal methodology, and so the specification calls for the use of marginal, so you can understand the change in emissions caused by an action.
Yeah. Let's cover that later. This is. We'll get into the weeds if we really start digging into kind of average versus marginal right now. But let's finish off it's a very important topic. But just want to make sure we finish the last bit here, and then we'll go through the questions perhaps, because there's a lot of questions. But Shimon. So you've shown how to do time shifting. How do I do that location shifting stuff we were talking about? I can't I've got something that's latency sensitive. I can't move the time. I need it to be done now, but I have some flexibility regarding kind of where I run it. Where would I, like, how would I kind of solve that? Yeah, how would I use the SDK API for that?
Sure. So let's say just for our case that we want to be running it at 8 a.m. and we're only going to give it a 5-minute time frame to look in. So one can once again use the emissions by locations best endpoint and then put in whatever regions we are interested in. So whichever ones we can consider. Normally, we probably will have some limitations as to how far or where can we move it. So let's say we're looking at UK South, France, and maybe some US regions. And what we'll get is we'll get in a response, if I typed in all the names right. Yeah, so we'll get what region at that time has the lowest rating. So in this case, we can see it's France. Sorry for the scrolling. And yeah, basically this only gives us one point of data. What we can also do is look, for example, at historical data. So look at a bigger amount of data and see how that location shift would have, if it was a good decision based on the previous data, or even look at the forecast data, so look in the future, if keeping it in our location or moving it to a different one might be more beneficial carbon-wise.
Brilliant, awesome. So yeah, so this is telling me France, and France is a lot of nuclear, so that's kind of tends to be low generally. I think there are oftentimes kind of questions around, you know, data sovereignty and stuff. But there's, for instance, in the US, there's multiple regions within the US, so you have plenty ones to choose from. Is there anything else you wanted to make sure we covered, Shimon, before we? I think there's a couple of questions in the Q&A.
Yeah, so I see a few questions about the date format. So basically what the SDK will provide you back is the UTC time. But what I can do is I can provide it in different time zones. So I am using UTC+1, which is the current, which is the UK time zone as well. So but it will always provide us back with the UTC time zone, so you can, when querying it, when using it, you can either convert it yourself, or if you're using an SDK generated with OpenAPI, you will generally get some kind of date time object, which you can easily manipulate to get whatever time zone you want.
Mm-hmm. Wonderful. So there's another question from Stefan. What is the sampling rate of emissions rating? For example, how frequent does it make sense to query in order to have accurate data? Do you have any thoughts on that?
Well, that is a good question. I mean, are we looking this? Also, I'm not sure what this is referring to. Is it referring to looking at our job, or how frequent does it make sense to?
Well, I suppose the granularity that we've got from what time is 5 minutes. That's the lowest level of granularity that we have. So from a 5-minute perspective, I suppose that's the lowest you can go. In terms of, you know,
maybe you can get Henry's input on this as well.
Absolutely. Can you quickly restate the question?
I think it's a question of like sampling time. So I know that what time has kind of a 5-minute, it looks like what time provides like data in 5-minute increments. Does it change in every 5 minutes? Does it change actually more likely every half an hour? Like if you're really building something that's carbon aware, like how frequently will that data change on your side? I think is the interpretation of the question that I'm seeing.
It's highly region dependent. So you can, sometimes the data will change every 5 minutes, sometimes it'll change every hour, but we reported it every 5 minutes. So you have the maximum granularity. We also see that people need different granularity. Let's say you have an hour-long job that needs to be run. You need to identify the cleanest hour, not the cleanest 5-minute period. And so you need to take all of the values in that hour to load.
Yeah, that makes sense.
And we've heard of some people running 4-day jobs. And so you have to start thinking about, is it better to pick a region rather than a time for things like that?
That makes sense. just really moving through quickly. I think we'll do another kind of four minutes or so of questions. I'll try and okay, I can see Dan's answering a few. So can we query a future time interval? So do we have forecast in the SDK, Shimon? Can we query a future? This is from Wing Ho. Can we query a future time interval? Say I know my workload will last for 24 hours, so I need to find the greenest time for the next 24 hours. Yep. Forecast, wonderful.
Yep. So what time does provide forecast data as well? I am not 100% sure, so Henry can correct me on that, how long in the future we can look into. But we do have an endpoint as well, which we can choose and then query to see what the carbon intensity is predicted to be at a particular location. So it works similarly to other endpoints, giving us data just for the future.
Yeah,
but
wonderful.
How long in the future it looks for, I'm not 100% sure.
We have forecasts up to 72 hours if that's been implemented in the SDK.
Perfect.
Wonderful.
So yeah, so it's 72 hours.
And I see there's a couple of questions that have been answered via typing, and I thank you for that. I just want to just maybe for the audio verbally. Yes, you do need an API key in order to use the SDK. For the duration of the hackathon, you will be provided one that's been generously provided by What Time. So when you register for the hackathon, we will send you your own API key. And then you can then deploy everything you're seeing right now on the screen is currently deployed on Shimon's local computer with his own API key. We have an online version of it, which is deployed via a shared key. So you can use that one, or you can deploy it yourself. So we'll provide you a hosted version that anybody can use, but then it's a shared resource, or you can have your own one that you can use, and everyone will be provided with their own API keys. They will only last for the duration of the hackathon though. So post the hackathon, you will need to source your own API keys.
Yeah. What's important to point out as well is that you can also use local files as data sources. So the SDK provides you the interface, but can also gives you the ability to plug in other data sources. So although What Time is the one we're currently focusing on, if, for example, your company or you just by yourself decide to use a different data provider, such as electricity map or some data you collected yourself, you can plug that in as well. So we do have already a plugin for electricity maps that is a work in progress and scheduled for next release for 1.1, which if you want to, you could probably use for the hackathon as well. But it is not guaranteed to be working fine yet, right? It's a work in progress.
Wonderful. I think given the time, I think we've got most of the questions answers. Oh yeah, so the last question I think is very related. Daniel's asking, are there any potential ideas for projects? Well, that's the next section of this this talk. Is we're going to get I think a bunch of people on. We just have some we can kind of like throw some ideas around for A, what other people have done in the past, B, some potential ideas, really just hoping to get some ideation from you. We also have members from our from some of the mentors from some of the sponsoring organizations are here as well, so they can then give some input into some of the ideas also. So should we bring on I think we have Naveem and yeah, they're on. Naveem's on. Okay. So I think I'm just going to throw some ideas out there. Naveem, I know that you've been looking at AI in particular in your world. So I was wondering if yeah. So do you have any thoughts regarding potentially some AI carbon aware solutions that you might want to share, something to inspire some of the people?
Sure, Asim. So AI is one of the material impact areas that we are currently exploring at Accenture. And how do you basically develop, train, and create inferences in an energy efficient way? And training an AI model, right, probably takes the maximum amount of carbon emission for a software stack. So along with creating energy efficient AI process, you could do time shift and location shift, right, to reduce your overall carbon emissions. And there are various use cases. For instance, how do you do distributed learning, transfer learning in a more energy efficient way, training when clean energy is available? How do you optimize your entire ML ops process and take all these benefits, right, and make it carbon aware? I have Vikrant also in the call who can talk about some of the work that we are doing as part of the labs.
Thank you. Yeah, Vikrant, if you want to share anything, please do. Yes.
No, I think Navid covered, I think, the important stuff here. So basically, going back to what we discussed from a carbon awareness perspective, right? So you could apply carbon awareness principles to a variety of software workloads. And if you treat AI as one of the software workloads, it has its own peculiarities in terms of the compute that is required, and there might be data residency issues in terms of where the data is stored and does it have to be transmitted to a location where the training or the inference is happening, so on and so forth. So I think AI therefore gives us, I would say, that interesting playground to test different carbon awareness strategies. Is it situating the, let's say, the training workload in a green location? Do I run the training workload in batches at green times, so on and so forth? So I think those are some of the ideas that we have been tinkering in the labs here at Accenture, and they might be worthwhile for the hackathon participants to explore and build on as well.
Yeah, I see AI and machine learning is just this wonderfully perfect use case for carbon awareness, because it can be very, it doesn't have, it's not so sensitive to where it's run. It can be shifted to different locations, and it's also not so sensitive to time as well. So you do have the option to kind of move it from one time to another. One other thing that I think is interesting, and something I've looked at from an AI perspective in the past, is sometimes you get very, very long training runs that are going to take many, many days, sometimes weeks. You perhaps don't want to pause the training run or stop it, but maybe you can just scale out and use more servers when the electricity is greener, and just keep it ticking along, but scale back down to a few. So I think that's kind of another way to look at it. Yeah, I think it's kind of interesting.
Yeah.
One other thing. Go on.
No, I was just going to say on your point that I think if you consider the AI training or ML training as a sort of a batch process, and there are so many batch processes and workloads that we have in enterprises. It could be even regression testing that we do as part of a release. And some of these batch workloads are not real time. They are not time sensitive in terms of when they run. So I think there is an opportunity for the participants to look at different kinds of workloads, time sensitive, some of which are not sensitive. Insensitive is not a right word, but still. I think that's an opportunity that I think we should explore in terms of classifying workloads and figuring out which strategy really makes a lot of sense.
And as someone who used to work in the financial industry, I can tell you there's lots of batch workloads in the financial sector as well. So that's definitely a prime location for this also. just to maybe kind of, I'll just talk a little bit on and if anybody else wants to chime in as well, like Ismail, maybe you want to chime in on this one. So I wanted to talk a little bit about web, because I'm a classical web developer who's does different things now. So I think web's like a wonderful example as well. There's a lot of stuff being done in the web space which I think could benefit from carbon aware computing. There's a lot of stuff that can't, because if you click on a web page, you don't want to wait 5 minutes for it to appear because the electricity is dirty. But for example, the things like what the Branch magazine's done, I think there's a wonderful, if you're somebody who's much more of a front-end developer, maybe you build web components or UI components. Can you build UI components which are more responsive and change behavior based off of how clean or dirty electricity is? I remember a while ago seeing a wonderful design think piece. I'm gonna apologize, I completely forgot her name, but but what would a carbon aware operating system look like? And it was things like, like your video player that you have, when the electricity is dirty, maybe that downgrades to a lower quality image. If it's really dirty, maybe it downgrades to just audio. Images, maybe images, maybe write a web component which downgrades images as well. Like, any other thoughts? I don't know, I'm putting you on the spot here, Ismail, but any thoughts you might have if you're not answering a question right now in the Q&A?
No, absolutely. I was just going to link, because I sort of framed this in the concept of a green mode design principle, that we should design everything with green mode. And the two principles that I suggest should be part of it is, one is graceful degradation. So we used to do a lot of graceful degradation 10 years ago, because there was so much variation between browsers. And then nobody talks about it anymore because they've more or less become standardized. But we can co-opt those techniques to gracefully degrade in accordance to carbon intensity. So that would mean that you have your green by default standard, you've already optimized your site, but that's not as sort of green as you can go, because you can't make a site. A really good example is the Branch magazine one that you showed. Sometimes you want the pictures, but you don't always want the pictures. So the second principle is user choice. So the user should be empowered to degrade gracefully the functionality to minimize their emissions when they don't need it. So that whole area of sort of carbon aware green mode design, or energy saver mode, or whatever you want to call it, is one area. It's something that we can also apply to hardware. You mentioned operating systems. So at the moment, all of our laptops and phones have the mode where when you are not plugged in, your battery is low, you have an energy saver mode. So another potential source of ideas here is to apply energy saver mode, not when you are unplugged, but when the grid is dirty. So if you have high intensity grid, you don't have to think about it. Your computer automatically goes into low energy mode, and you know that you're saving energy yourself, and you're also saving the environment. And then there are things around the Internet of Things. So at the moment, a lot of devices are unnecessarily constantly connected and constantly polling, right? You might have your watch checking in all the time, but many of these apps don't need to be on all the time, right? The process can be asynchronous, whether, for example, synchronizing your exercise for the day. You could time those things for when it is energy efficient. So the whole Internet of Things world is one where you can identify which processes can be interrupted. And I think there's some cool initiatives out there that we can share later. But the last two concepts that I'd like to just share as a broad line of thinking people might want to take. One is what's called delay tolerant networks, and the other one is intermittent computing. So the idea of one is, if things don't need to be processed instantly, you can delay them and then make them happen later. And the other and it's the same kind of concept, is you could, for example, at the moment we're talking about how to be only on green energy, but you could also have an interrupt switch. If the energy gets past a certain level of dirtiness, as it were, of intensity, then interrupt my process. And so you're kind of having a more inclusive approach to your energy consumption. You're using green and normal energy, but you're drawing a line at something that is there. So that's some of the ideas and principles that would approach.
And I've seen, that's a really good point about, so FY, if you want to learn more about green networking, which is the delay tolerance stuff Ismail was talking about, there was actually a podcast episode on podcast.greensoftware.foundation with some of the researchers that have been exploring that space. And what's interesting about green networking is actually it's been leveraged by NASA for ages, because if you want to send packets of data from Venus back here, you have to deal with delay. And you're right, that's a very good point about, I completely keep on forgetting to mention that intermittency, because, you know, just we've spoken about shifting, but actually just pausing for 5 minutes during the worst times can sometimes have as good an impact as kind of like shifting things around. And one of the things an idea I would love to see, I've been saying this idea for years, but no one's built it yet. So maybe I'll do it one more time. What if my laptop only charged or stopped charging when the intensity was high? Like, I've got a battery, it's okay, I'm not going to fall apart. If it's over 80%, that's okay, I'm happy, just let it don't let it charge for a while. There's other stuff that's going on. There's other, go on.
Just going to say, maybe one key design concept that people can take with them is event driven. So any application, any project, any tool you have that can be triggered by an event, this Carbon Aware SDK is your friend. So it doesn't matter what it is. If you can say, if this then that this can be the energy grid. So you can take that concept and apply it to any area of life.
Create a trigger for Zapier and if this then that and all those other things. Like, that'll be a great tool. And just Naveen, just really quickly, I want to say just one more thing, because I'm going to stop talking after this. There's another really interesting research going on, which is overclocking. I never really thought about this, but when the electricity is greener, use more of it. Overclock your machines. Spin up the cooling, do more than your machine is normally capable of doing, because electricity is green. You might as well use it up. So that's just another idea. So Naveen, do you want to just, you got your hand up?
No, I just think other idea I think which people can relate with is the entire DevOps process, right? How do you do schedule builds? How do you do testing and everything, right? Everything can wait actually, right? So Carbon Aware shifting might be a very good use case to optimize your DevOps process, right? And make it more carbon aware and energy efficient.
Very good point. Let's just quickly, unless anybody else wanted to have a minute, there's a couple more questions in the thing. I just want to really quickly, oh, hang on, sorry. Oh, everybody's answered the questions already in the chat. Okay, wonderful. Don't know. I just wanted to make sure Henry has a moment. I don't know if you've thought about this, Henry, but this is your time to express any wishes and dreams for things you hoped existed in the world in the terms of software and carbon awareness.
I think really thinking about how to leverage this time-based and location-based, we see a lot of interest in this concept, but we would love to see like features or capabilities that people could easily integrate into their process to automate a lot of their other workflows to kind of become carbon aware. We kind of need the shovels for the gold miners. There are a lot of developers out there who aren't even thinking about carbon awareness, and so we need tools for them to make their other applications clean. I don't know if that's a useful.
Yeah, because no, it's a really good point. I think that also speaks to the fact that you know, we're talking about using carbon aware, like the mission of the foundation is to reduce the emissions of software. But software runs the world. You know, you could you could build something using this API which would charge, I have an electric car, which could charge my car. I know there's many solutions which could charge my car when it's greener energy. And actually, Dan, I just remembered we had a conversation previously about like my entire house is actually, let's not call it smart, because I think that would be too strong a word for what it is right now, but it's somewhat intelligent. And my whole house is like, I can control everything via an API from Samsung. See, that might be an interest. I don't know, Dan, do you want to jump on? I don't know if you have some thoughts on that.
Well, I think what I was going to mention is, I don't know if some people have thought about solar panels for their houses, but obviously here we're trying to think at scale, and that could be the case for companies. But I know that at home, I've got the ability to interact with it, with basically my solar production. And as you guys said, I can say I've reached the point where now I'm about to export the energy to the grid. So it's, it can't be greener than that. Why don't I just like use it still for myself to charge the spare device, charge the car, etc. All those basically scenarios that you were mentioning earlier around using more of the green energy for battery operable devices.
Wonderful. Does anybody else, in the last couple of minutes, any other thoughts or ideas that people have they might want to throw and share?
Just Asim, I was going to also kind of try and advertise a little bit the SDK as well, because at the moment we're on release 1.0, and the truth is the hackathon is, a bit of a celebration for us that this hackathon is out there, it's live, and that means that now people can really make things out of it. Before it was a little bit harder to integrate into real life solutions. Now you have the ability to put them into your projects and do something concrete with them. But it doesn't mean that it stops there. This is just the very, very beginning. This is scratching the surface. So your ideas can also be about improving the SDK, thinking about new cloud providers that we could interact with, think about like new languages, think about new integrations we could make that improve the SDK in itself and basically help. And ways you can also go about that is in your companies, go and talk to other services, other departments and other people, and see what they're after and harvest ideas this way so that they're relevant to you and to your company. So you can also get the sponsorship and the support from your teams to build those features, and also potentially form teams within your companies or with your colleagues. So that's, a little like mixed plugs I wanted to put it out there, because it's important to remind people of that. Not necessarily always just think about the shiny improvement, but also about like, the engine itself.
Very good point. I apologize. I completely forgot to call out the SDK as well. Yeah. Yeah, wonderful. Just want to remind. So we're coming. Go on.
Add to that last comment, because I think it's really important in terms of the range of ideas that people can pursue. So again, as a big picture thing, there are two ways in which you can look for solutions. One is a solution that's happening in your machine, as it were, literally in your machine. So it can be something that people put into their own machines and it works. And it can be something that is happening in a central place in the web, whether that be sort of the central place in the web or your own central place in the web. And that means that the solutions you can come up with can be purely command line tools. So a script runs and it does it in your machine. Or it can be API tools. You go for the request, you get the data, and you work with that data. So don't think just about API or just about the machine. Think of absolutely any use that you could do with either of those.
Yeah, good point. And a CLI is a great idea. Maybe like a CLI called Carbon, which pauses the execution of the command that comes after it until the carbon's clean. That's a good idea. The wonderful, thank you. So just want to call out one more thing. Register. On our website. We have projects that people have already proposed on the hackathon platform, and we will making sure you see them. We'll be sending you lots of emails so you know what's available. If you don't have your own idea, you can feel free to join one of those existing projects. If you have an idea, propose a project on the platform. And the platform we're building, if you have an idea but not a team, We have matchmaking features. We have the ability to help you nurture a team around yourself. Perhaps we will help you, promote some of your projects on our channels, on our social channels, to help you build up a solution. Our goal is just to get as many wonderful solutions built and to help you build the best carbon aware solution possible. So please kind of propose your ideas, but we're waiting to see, the creativity that people bring to this. And we're also, lots of mentors are here. So as soon as you propose a project idea, we'll assign you a mentor just to help you with, questions and answers around the space. So we are here, we're really trying to support you in the creation of your project. We're not just going to leave you on your own. So yeah, please register, join a project, propose a project, and if you propose a project, we'll assign a mentor and we'll help you to really get that project up and running and really get you some help to execute that project. Is there anything else I haven't mentioned? Anybody? Anything we need to cover?
I think just for anything left, if people have any more questions or want to do those interactions, they can use the Discord to get in touch. So obviously, there might be some things here that we have covered, but maybe not in exactly the way it was intended. So if people have any more questions or want to get in touch directly with us, they can use Discord for that. Sorry, Doa.
Yeah, I was going to say that we also plan to do a few more of these events to go a bit more deeper into some of these topics and ideas, and also maybe actually at these events help you guys form teams. I'll put the link for our Discord channel in the chat. And yeah, feel free to reach out to us. We will be sending the video of this webinar and the presentation that Asim did tomorrow, hopefully, to everyone who's joined us today.
Wonderful, awesome. Thank you to all our panelists. Thank you to everybody. Thank you to all our attendees. We're really looking forward to you joining us at the Carbon Hack 22. Thank you. Bye.
Thanks, everyone.
Bye.